Here is another challenge, munging passwords. What is a munged password? You've all had passwords, right? For example, let's say your password is password, right? Now, obviously this is not very secure. You want to be a little more cryptic with your password. Instead of creating elaborate passwords, you could just substitute some of the characters in your password with some symbols or cryptic text. For example, the same A could be substituted with an ampersand. The letter O could be substituted with a 0. So essentially the password is pass. This is a 0 password, right? Well, granted that the best hackers can easily hack this because they know these substitutions. But at least for the common user, the second password, this munged password, is much more safer than this password. Now, what is the challenge here? The challenge here is to create a function, right, that takes in the password as a string and applies this transformation. So it substitutes the character A with ampersand or the @ sign. I'm sorry, I think I must have been spelling this symbol at with ampersand. I'm sorry about that. So this is at, as in what you have in your email. And I for the bank character, exclamation, O for 0, and S for $. Now, there are more popular substitutions. You can just go to this Wikipedia link and you'll get many more substitutions. But that's not the point. We just want to create this function and I wanted to illustrate a point. Now, say the function is going to be something like this. Def password munging. It's going to take in a password, which is just a string, right? And then we need some of the characters in this password to be substituted with some other characters, right? Now, how do you maintain those map of characters? What do I mean by a map? Map is something like this, right? So A needs to be substituted with the @ sign. 0 or O needs to be substituted with 0, and I needs to be substituted with an exclamation, so on and so forth, right? So this is called a map. What is an appropriate data structure in Python for this kind of mapping? Of course, it's the dictionary, right? So dictionary has keys and values. So these could be keys. So these could be keys, and these would be values, right? Okay, we have found out the data structure that we need to use to store this character map. The next thing is, in order to do this substitution, can we do the substitution directly? Like, for example, say the password is password, right? Like so. So this is a string. Now you can refer to individual characters in a string like so. This is for example, if you want to say password, or let's say this string is available in P, can you change the character at, let's say, this index? Meaning, can you say P of, this is 0, this is 1. P of 1 equals another character or string? Is it possible? No, it's not. The reason being, strings are immutable. So once a string is created, you cannot change the individual characters in a string. So how do we go about doing this substitution? Because strings can be changed. So the way to do, there are a couple of ways to do it, and the easiest way to do this is by converting this string by converting the string to a list, right? So how do you do that? Let's say password is the string, right? So this string is stored in password variable, and we say password equal to list of password. This is not the literal text but the variable itself. So what we are saying is, hey, this is a string that I'm passing to you. Using this list constructor, create a list out of this string. So what happens when you create a list out of a string? So here is our string. When you convert this to a list, so it creates a list like this with P as the first character, A as the second character, S as the third character, S again as the fourth character, so on and so forth. Password, P-A-S-S-W-O-R-D. Now, the reason why we are converting this string to a list of characters, single characters, is because lists are not immutable, they can be changed. Meaning, if you want to change this element, right? So all you have to do is say password, which is our list variable, of 1, because this is 0 and this is 1, equals @ symbol, right? Similarly, this is going to be at 1, 2, 3, 4, 5. Password of 5 is going to be 0. That completes our substitution. Finally, when we return the function, we don't want to return an array, isn't it? We want to return a string. That's what we are being asked. We are passed a string and we return a string. So how do you create the string out of this list now? So you take this and you use the join function. So join is basically a function of string where you say an empty string dot join and an iterable. The iterable in this case is going to be this variable, right? So join of password. So what does this do? It creates a concatenation of all the elements in this list separated by this string. All the elements in this list are these characters P @ S S W 0 R D, right? It concatenates all the elements of this list by separating them with a blank. So this is going to be a blank character. It's not a space, it's blank, just two quotations with no space in between. So what happens when you do that? It becomes P, first character, and then no space, because that's what we want to concatenate here, right? And then A, and then no space, and then S, this is going to be @ S S W 0 R D. And that's what we're going to return. Easy, right? So let's type this out. So the function that we're going to create is called what? Password underscore munch. And it's going to take in a password, right? It's going to take in a password, basically a string. Now what do we need to maintain here? We need to maintain a character map. And we have discussed that the best way in Python to create this map of characters is a dictionary. So how to create this dictionary? Well, let's put a little comment here. So this is a dictionary to store the character map for substitution. And it's going to have the key values, right? The key is going to be the character that we need to substitute. For example, A needs to be substituted with this @ symbol. So A needs to be substituted with @ symbol. Similarly, we type in all the rest of the characters that need substitution. So this here is our character map. what do we need to do next? Since strings are immutable, we need to convert the string to a list, right? And for that, we are going to use the list constructor. So password underscore list, which is a list version of the string that is being passed to us, can be created by using the list constructor. If you just try to print this, let me run this. See, if you try to print this password after constructing the list from it, you see the list is going to be something like this. It's going to break up this string that we have passed along into its individual characters and store it in a list. Now what? Now we need to do the substitution. We have to substitute a character that is in this map to its corresponding map, right? We have to substitute each character that is in this list and replace it with a corresponding map or mapped character. Okay, how do we do that? Way to do this is for every character in this list, right? So for every character in this list, we have to verify if it's available in this character map. If it is available, then do the substitution. Otherwise, just keep going, right? So how do we do that? We have to basically try to get this mapping from this munged character dictionary that we have created, which is pretty easy. So let's take this out. We don't need this anymore. Basically, we are trying to iterate over all the characters in this list, right? And then try to do what? If this character is available in this character map, then do a substitution. If not, just keep going, right? So how do you find out if a character is available in the keys of a dictionary or not? Well, you could do something like this. If munged characters of char, right, equal to char. So what this gives you, munged characters of char, is we are trying to essentially ask this dictionary if it has a value for the key of, let's say, P. The first one in this list is P, right? Does it have a P as a key? No. Does it have an A as a key? Yes, it does have A as a key. And the corresponding value is @, right? Okay, if it is the case, then what do you do? Well, we have to replace this letter in the list with the corresponding value, right? How do we do that? Well, in order to do it, we need to be having the index at which we are currently running. For example, we are running, let's say, at P, 0, the first iteration in this for loop, right? When you're doing this first iteration, index is 0, it doesn't match, so we move on to the next iteration. The index is 1. We need to replace it because there is a map found here. But how do we replace it without knowing the index? So a for loop in this form doesn't work out. For that, we have to use enumeration. So we say, now we got an index. Enumerate function on an iterable gives you not just the element in that iterable, which is a char in this case, it also gives you an index, basically a tuple of index and character, corresponding character, right? Now, if a match is found, then what do? You replace the corresponding character with the corresponding map, right? That's it. If it is not the case, if it is not a match, if the corresponding map doesn't find a corresponding character key, else What happens with else? You don't have to do anything because the list is already there. You just pass, right? After this loop is done, just return the password underscore list. Easy, right? Let's try this. Okay, now try to execute this. Ooh, what does it say? Key error, P. What does that mean? P is the first character, right? So it's trying to go through this loop in this for loop. It's trying to go over this list and it finds that P is the first character here, right? It's trying to find out if this dictionary has a key called P. Well, it doesn't, right? We only have keys for A, I, O, and S. So the weird thing about getting keys this way is that if the key is not found, which in this case is not found, it throws an error. But that's not what we want, right? We want some kind of an indication saying, yes, I have found it, or I have not found it, right? We can do this in a couple of ways. We can catch that error and then do something about it. Or we could use the get function of dictionaries, which is a much safer way of trying to find out if there are keys of a particular character or element or not. Like how? Like so. Now you see there is a get function in a dictionary that if you pass a character or element to it in the dictionary, it will give you whether, if it has found the character, it will give you the, so for example, if it has found A, it will give you the corresponding map. That's good. If it has not found it, it will return none, N-O-N-E, none, right? Let's try this now. Okay, and password. Okay, that doesn't work either. Why is that? Because we are trying to compare the value here with the corresponding character itself. That's not the case, right? So if it is not equal to null, only then you do the substitution. All right, now it seems to have got the corresponding conversion, right? See, the A has been replaced and the 0 has been replaced. Now, what are we returning here? We have passed in the password as a string and we want to return the password that has been substituted or munged as a string. But we are returning what? We are returning a list. So like I said, so we need to convert this list to a string again, right? So how do you do that? You use the join function. So password munged is equal to string.join of the list. And we return this, right? Let's run it and then run it. So you got your password, right? A has been substituted, S has been substituted, and O has been substituted, right? So this is how you can munge passwords. Once again, so this is our map where we have the substitution defined and it's a dictionary. And then we have converted the string to list. Why did we do that? We did it because a string cannot be changed. It's immutable. So we need to be able to substitute the single characters in a string. And what better data structure than a list? So we have converted the string to a list. And then we have used the get function of the dictionary to try to compare the corresponding key and to see if the key is there. If it is there, then get the corresponding value and substitute it in the corresponding index, right? And finally, we convert the list back to a string. So this is the reverse process, list to a string, and we send it back. So that's how we can munge passwords. The key learnings being how to convert or why to convert a string to a list, and how to convert a list back to a string, and how to get the elements of a dictionary, the keys in a dictionary, and what happens if there are no keys. How to safely get a key value element in a dictionary if it is not available and without causing an exception. So that is password munging.